Hey YouTube, it's Chris, and welcome to the SQL Fundamental Series. In this series, I'll be teaching you some of the basic concepts of SQL that I've learned both in my higher education and professionally as a data analyst and a data engineer. This video is going to be focused specifically on the clauses that you will find in a SQL query. If you haven't already, please be sure to set up a sandbox so that you can follow along with the code that I'm writing in these videos. If you're on Mac OS X or Windows 10, I have linked the videos below in the description so that you can set up that sandbox more easily. As you follow along and write the code that I share with you and the examples that I share with you, I promise that these concepts will be solidified for you and you'll be on your way to learning and mastering SQL. Alright, so first things first, we need to make sure the PostgreSQL database is running on our environment. Since we did the install, it could have stopped if you restarted your computer or shut down your computer. So what I'm going to do is I'm just going to open up the Ubuntu terminal right here. And I'm just going to type in sudo service PostgreSQL. And let's just put status to see if it's running first. It looks like it's down, so I'm just going to use that same command, and I'll put start instead of status. And that's going to start up our PostgreSQL database. Let's look at the status again. Looks like we're online. Awesome. Okay, let's go ahead and open up our IDE. And we have the AdventureWorks database connection saved from the setup video. So let's click on that and click connect. Alright, so the first clause that you typically see in a query is the select clause. And it's typically followed by an asterisk or a column name or names that you are selecting. Typically, these columns are from a table in the database. However, select actually can be used without a from clause and without any column names or without referencing a table in the database at all. But this is only for literals. So an example of this would be something like this. Select hello world. And that's it. We can hit run. It returns hello world. Another example of this is we could type 1 plus 5 and hit run, and that would give us 6, right? But like I said before, if we were just to use an asterisk like this, and then select a table from the database, we'll go into human resources schema and we'll use employee. Let's type human resources dot employee. This is essentially saying, give me all of the columns from the employee table in the human resources schema. So I'm going to go ahead and run that. Oh, I didn't put my from in. So yeah, you have to put from, select star from human resources employee. And this returns, like I said, all of the columns in that table. Now, what if you want just a specific few columns? We can do that by just typing select job title, which is a column in that table, hire date, and salaried flag. Just a couple of examples. We hit run, it's only going to return those three columns for us. Now, you can actually run functions and make calculations on these specific columns if you've called them like this. Like an example of this, so we could come in here and we could type upper and encase the job title in parentheses. We'll leave hire date as is, and we'll create a function that adds a day to hire date. Let's just say hire date plus 1. And then we'll leave salaried flag as is, and then let's just add another literal and just call this column, every value in this column will be active. And we'll just call that status. So if I run this, just to give you an idea of what it would look like, so you see those job titles, but they're in all uppercase letters. It's invoking this function right here. We have our hire date, as well as adding a day to that hire date, the salaried flag, and the value active for each specific record. Awesome. So the next thing let's talk about is selecting a distinct list, right? So in this column, in the job title column, we'll call this as job title. If you notice, the upper took the column name here because we used that function, but we can alias it and call it as job title. So if I run that, if we run that, I changed that column name from upper to job title, so that's good. But notice in this, we have two design engineers, right? We have two research and development managers. So maybe we want a list of all of the specific job titles. And what we could do, I mean, you could start and you could say, hey, give me all of the job titles. But that's going to give you duplicates. Job titles. What did I put? Oh, job title, excuse me. So we can put job title. But that's going to give you duplicates. See, again, you have some of those design engineers. So maybe you want a list of just like a non-duplicated list of the job titles. So in order to do that, we just add a distinct to the select clause, right? So if I run that, notice I have a distinct list of those job titles. Now without the distinct, or with the distinct, I have 67 unique values. And then without the distinct, we have 290 rows. So you can see a lot of duplicate job titles there. The next clause we're going to talk about is the from clause. In the from clause, we specify the tables used by the query, along with a way to maybe link multiple tables together through joins. And we'll talk about joins a little bit later. But these tables can be existing in the database. They can be in memory. An example of an in-memory table, would be a subquery or a view. From our last queries, you can see that we are selecting a specific set of columns, or all columns in this case, or the job title column in this case, from the human resources schema and the employee table. Now, if we wanted to turn it into a subquery, we could surround the query in parentheses and add an outer statement. And this is what that would look like. So let's go back to selecting, let's say, upper job title. Right, we were using that upper function before. Let's say as job title. Let's bring back the hire date. I'll type hired date +1 as day after hire date, salaried flag, and I think we had a literal in there, active as status. And so in order to create a subquery, you can just give ourselves a little bit of space here. You can say select star from parenthesis and parenthesis. And then let's just call that query temp. So essentially what this is doing is it's just selecting everything that's returned by the query in this parentheses. Right? So if I run this selection, it's going to look as if the query, we just ran the nested query. But let's say we just want to select something specific out of there. Maybe we just want to select the status column. Or maybe we want to select the day after hire date column. You get the idea. Besides subqueries, we can also include table links or joins in our from statement. So for example, let's get rid of this. We can come in here and say left join. And there's missing information in the employee table. If you look into the employee table, there's no first or last name for an employee. So maybe you have somebody asking about what job title, who covers what job titles, right? So that information is found in the person schema and the person table on person.business entity ID equals employee.business entity ID. So now we're linking the primary key from the employee table and the primary key from the person table together. And now we can call values from the person table. So if we come up here, we can add person.firstname and person.lastname. So if we run this, that should give us the name, as you can see, of the CEO of the company, as well as all the other job titles that are in this table. Notice in this query that I had to put the table name, i.e. Person at the beginning, right? And it's actually best practice to come in here and type in employee and alias each table with the table, or alias each column, excuse me, with the table that it is coming from. So in that example, I put employee. I think all of these came from the employee table, except for the first two columns, right? This is really strenuous to type out employee or person for each specific table, especially when you're referencing a column inside of that table. So what we can do is we can actually create an alias for it. And this is what that would look like. So after the employee table, after calling it in my from statement, I can put an E right here. And after calling the person table, I can put a P right here. So now I can replace all of these with a P or an E. For these ones, we'll put P, P, E, 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 E. And if we run, we'll get the same results. It's a lot less work for you, and you can quickly alias table names. Excuse me, you can quickly call table names through the alias. The next clause that you will typically find inside of a SQL query is the where clause. The where clause is a mechanism for filtering out unwanted results from the data set. So for this example, let's look at all the salaried employees from the employee table and eliminate the non-salaried employees. So in order to do that, we would just come down here and we would type in where salaried flag equals true. And notice we're referencing this salaried flag column, and you see the falses that are in here from when we ran it last. If we go ahead and run this, now it's just returning the 52 results. They're the 52 employees that are salaried. So you can also add operators to this. So you can filter on multiple conditions. Maybe you want to see all of the salaried employees that were hired since 2019. So we could add in and statement right here and just say and E hire date is greater than or equal to 2009 01 or you could do 2019. Whatever date you really want, right? And so we can hit run. We need to surround this in quotes because it's a date. Perfect. And so now this data set is showing the 39, and I'm getting that 39 number from down here, right? The 39 employees that are salaried, and they've been hired since 2009. So some of these other examples, like instead of an and, I could use an or, right? Like the employee is salaried, or they were hired since 2009. You can use different operators, and like, we'll have a whole nother video on the specifics behind the where clause for multiple filtering criteria, but this is just the clause that you'll see. Something else that I may have forgotten to mention is you typically always see the clauses in this order. So like you would never put a where clause above a join, right? Or the join above the from. So this is the exact sequence that you're going to see these typical clauses inside of a SQL query. All right, so after the where clause, typically you see the group by and having clauses. The group by clause is used to group data by column values, which will give you a quick view of aggregated data. So to give you an example of this, I'm going to go ahead and I'm just going to delete this query. I'm going to type select E job title, and we'll say, let's do account, E business entity ID. We'll call this as number of employees. Say from human resources. We'll pull from that same employee table. And you can see I proactively alias the column name. So let's call it E. And then the next thing, so we're not filtering out any criteria. So we're just going to leave out our where clause. But let's throw in a group by. Because with this aggregate function right here, this count, we're going to need to put in a group by or else it'll break the query. So we're going to say group by the job title. And if I run this, what it will do is it will show, based on job title, how many records in the table have that job title, or specifically how many business entity IDs, which is our unique value for the table, right? It's an identifier. So what we're saying here is there's 2 database administrators. There's 3 design engineers. There's 1 human resources manager down here, right? So this is the group by clause. Now, to add to that, we can say we can add the having, HAVING clause right here. And so what we can do here is we can filter the group by. So you don't use a where when you're filtering the group by results. You use a having. And we can say having count the business entity ID, right? The same code that we see here on line 3. And let's say we want to see job titles that have at least 2 employees in it, right? So we could just put is greater than or equal to 2. And so this will return, so like before I run this, just let's think about what this means. So that means the human resource manager, because there's only 1 employee that's in that job title or in that position, they will be removed when we run this, right? Purchasing assistant, they have 2 or more, they'll remain. So I'm going to go ahead and run that just to show you. Yep. So all the remainder are job titles that have at least 2 employees in them. All right, and the last clause that we'll go over in this video that you typically see in a SQL query is the order by clause, which allows you to sort the output, this window right here, by ascending or descending order. And you can choose how you want to sort that and which column you want to sort that by. So for this example, let's add a new line here on line 7, and let's just say order by, and then we'll say num employees, referencing that second column. And let's just say descending, right? So now if I run this, we're getting the job titles that have the most employees in them at the top, all the way down to the job titles that have the least number of employees in them at the bottom. Now, if we change that DESC statement to ASC for ascending, and we run that, then it would just be reversed. Hey YouTube, it's Chris again. I hope that you learned something new about SQL in this video. If you did, be sure to like the video and subscribe to my channel where I will be pushing out new SQL related content. Thank you so much, and I wish you well on your journey of mastering the SQL language.